Mabuhay everyone! Welcome back to our math class. So for today, we are going to have a very easy lesson that is connected to our lesson on scatter plot. So we are going to focus on today about line of feet. So just like what we did before, we are going to watch this video, the video discussion of our lesson. Please listen attentively and understand what you are writing. Okay, complete the guided notes. And after this one, we are going to proceed on our Alex activity on line of feet for independent practice. So what is line of feet? If you will observe on these three images, okay, you see lines in the middle of our scatter plot. These lines are what we call the line of feet. This one, this red one that's moving, and also this one. Okay, that is the line of feet. What is a line of feet and what does it mean for a scatter plot? Okay, we are going to find out as we listen to this video. Okay, so at the end of this video, our goal is to determine how to draw lines that fit a set of data and use them to make conjectures or conclusions. And remember, we are also going to write the equations for lines of fit of a set of data and use them to make conjectures as well. Okay, so we're going to have insights and interpretation of our lines of fit. Okay, don't worry, you got this one. This will be quick and easy for you. So let's get started. So when data are collected, the points graph usually do not form a straight line, but may approximately a linear relationship. That's why a line of feet is a line that goes through the center. Okay, a line of feet is a line that goes through the center and it's very close to most of the data points. Okay, so as you can see, this one is our line of feet. Okay, it is an estimate that models the relationship between the two variables on the scatter plot. Okay, so if you will observe this line of feet, it's actually dividing our data points into two, right? Half of it on the other side and the half of it on the other side as well. Okay, that is what we call the line of feet. Okay, so let's have more examples of the line of feet so that we better understand what is the use of it in our scatter plot. Okay, so let's take a look example for this one. The scatter plot shows the weights and ages of baby elephants. So to draw a line of feet, remember, draw a straight line so that about half of the points are above the line and half of the points are below the line. Okay, if you will observe this one, right, this is our line of feet. Okay, and as you can see here, because most of the points lie close to the line, then this model is a good fit. Okay, a good representation of the relationship between the ages and the weight in pounds of our elephants. Okay, on the other hand, we have another example of our line of feet. This is our line of feet. Okay, so for this example, the scatter plot shows the number of visitors to a ski resort on days with various high temperatures. Okay, if you can see it as we draw the line of feet, right, most of the points do not lie close to the line. Okay, then this model is not a good fit. It's like it has a weak, okay, linear association. It doesn't mean that the higher the temperature, the lower, okay, or the higher, okay, our number of ski visitors in our resort. Okay, so that's how to determine, okay, if it's the model if a good fit, if the points lie so close to our line of feet. Okay, it will not be a good fit if most of our points are away from our line of feet. Okay, moving on, okay. So I have another example of a lower line of feet. So the scatter plot shows the relationship between the math scores and the number of hours certain students slept on the night before the test. Okay, I'm pretty sure of you when you have a test, most of you are staying late to study. Okay, so remember when drawing a line of feet, ignore the outlier at 0.499. As you can see, this is our outlier, right? Okay, other than the outlier, most of the point lie close to the line, so the model is a good fit. Okay, so as you can see, most of our points here, okay, are okay, close to our line. It also shows that okay, the more hours you sleep here, look at this one, okay, the higher your test scores. Okay, there is a strong linear association for the number of hours sleep and the test scores. Okay, it means that you have recharged your brain. Okay, before the test, you have enough sleep. That's why your scores are getting higher. Okay, so again, ignore the outlier as you draw the line of feet. Okay, so let's now practice drawing the line of feet. Okay, let's have this one. Okay, for our first example, okay, we have here the table shows the number of hours people train in a month and their 5K race time. Okay, draw and assess a line that seems to represent the data. So as you can see, we have our scatter plot, and our time for training will be our x-axis, and the race time will be our y-axis. So, as you know, as we represent data on scatter plot, we just treat them like a point. So we're going to plot our points as an ordered pair. So we first have 5 and 41. So this is our 5. The point is 41, so it's somewhere here. So 8 and 34. So 8 and 34 is somewhere here. 12 and 35. So 12 and 35. So maybe it's here. Okay, 18 and 27. So 18 and 27 is somewhere here. 25 and 28. 25 and 28, it's almost 30, so it's here. Okay, 30 and 21. 30 and 21. So 21 is here. So 32 and 16. So 32 and 16 will be somewhere here. We have 23 and 20. So 23 is here in the middle and 20 will be in here. Okay. So after you plot your points, your data points in your scatter plot, we are now ready to draw our line of feet. Remember, when you draw the line of feet, it must be on the center, half of the points above it and half of the points below it. Okay? So let's say this is our line of feet. Hopefully I can draw it very straight. So let's say take a look at this one. Okay, so that will be a possible line of fit for this example. Okay, so what does it mean? Okay, as you can see here, okay, most of our points lying close to our line of fit. So therefore, this model is a good fit. Okay, so basically, that's how you draw your line of fit. Plot the points. Okay, draw the line, which is center. It means that half of the points are above it and half of the points are below it. Okay, and then try to see how spread are the scores in regards to your line of fit. If they are close to the line of fit, it's a good model. Okay, it's a good fit. Okay, if they're scattered far away, then it's not a good fit. Okay, so therefore, because most of the points lie close to the line, the model is a good fit, like I told you a while ago. Okay, so it's a good representation of the time in training and the race time. Okay, so let's move on to the next example. Okay, for our next example, we have here, okay, the table shows the average traffic volume and average vehicle speed on a certain highway in a week. Okay, so we're going to represent our x-axis as our traffic volume, this one, and our y-axis will be our speed. Okay, so this is x, this is y. Okay, so as you can see here, for our traffic volume, our smallest is 5,200 and our biggest is 7,600. So if we're going to use the range 5,000, okay, to 8,000, so that will be probably a good way to represent our x-axis, okay? And we can have an interval of 500 to fit in our coordinate plane. So this one is 5,000, so I'll just put 5K. And then this one is 5.5. We have 6K, 6,000. And then 6.5, 7K is 7,000. And then 7.5, and then we have 8,000, 8K. Okay, and then I think that will be fine already. And then for our vehicle speed, our smallest is 37 and our biggest is 58. Okay, let's say we can start with 30. Okay, so I'll start with 30 and then we can move on by 5. 30, 35, 40, 45, 50, 55, and then 60. Okay, now let's plot our points. So we have 6,300 and then 45. Okay, so 6,300 is after 6,000 and then 45 is here. So let's say 6,300 will be like here. Okay, 5,500 and then 50. So 45, 50. Okay, 5.5 and 50 will be here. We have 6,053. 6,053 will be somewhere here. 5,258. So 5,258 will be here. Let's see here. We have 7,143. 7,143. So 7,143 will be here. 7,038. So 7,038, it's almost 40. 7,637. 7,600, it's after 7.5. And then 37 is somewhere here in the middle. Okay, so we have graph already our data points. Now let's draw our line of feet. Again, we're going to draw it at the center. So this will be the center of our line. So if we're going to do it manually next time, we're going to use a straight ruler for that. Okay, a straight edge. So if you will be observing our line of feet and our data points, as you can see here, half above, half below, and they are so lying close to our line of feet. Okay, so therefore we can say that this model is also a good fit. Okay. Okay, because most of the points lie close to the line, the model is a good fit. Okay, don't forget to complete your graph and also write the conclusion based on our lines of fit. Okay, so how do we use the line of feet to make conjecture? Okay, so a line of feet can be used to make conjectures about data that are not graphed on a scatter plot. Okay, so the scatter plot shows the distance traveled and the cost of airline ticket. How can you use the line of feet to make a conjecture about the cost of an airline ticket if the distance traveled is 1,300 miles? Okay, remember, when we say conjecture is a prediction. Okay, what do you think will be the cost, right, if we have traveled 1,300 miles? Okay, because not all data are graphed in our scatter plot, but we can use the line of it to make prediction. Okay, so taking a look at our graph, our scatter plot, okay, let's try to find our 1,300 miles. So this one is 1,300 miles in between 1,200 and 1,400. All we have to do is to check all the way up there. What is the corresponding y for that? And as you can see, the corresponding y is 275. So we can predict that if you will travel 1,300 miles, you will pay $275 for our airline ticket. Okay? So it's very nice to have a line of feet to predict our costs. You can also make, for example, if you want to travel 1,000 miles, okay, you will pay 225. Okay, if you travel, let's say 700 miles, you will pay 175. Okay, so we just have to learn how to interpret our graph. Okay, so for that example, we said that if the distance travel is 1,200, then the reasonable price to expect for the cost of the airline ticket will be around $275. Okay, that's not in our paper, but that is an example. For the next one, this one will be on your paper. Okay, so let's make conjectures using lines of feet. So the scatter plot shows the diameter of different trees and their heights. Okay, if you're going to use the line of feet, okay, Make a conjecture about the height of a tree if its diameter is 8 inches. Okay, so we just have to spot 8 inches. This is 8 inches in diameter and go all the way to our points. That is our point for that one, and it corresponds to 24. So we can say that if the diameter of the tree is 8 inches, its height will be 24 feet. Very easy. Okay, so you can predict that the tree has a diameter of 8 inches. Okay, that is the point. The height will be 24. Okay, because the y-axis represent the height. Let's have another easy example. Okay, the scatter plot shows the amount of money earned by different servers at a restaurant and the number of tables they serve in a week. Use the line of feet drawn to make a conjecture about the amount of money a server will earn if he or she will serve 225 tables in a week. Okay, so let's find 225 with our number of tables. It's in between 200 and 250. That's 225. Let's go all the way up. As you can see, that is our point, right? And then if you will see that one, it's in between, okay? Our 1,000 and 1,125. So how do we estimate the amount of that one? Very quick and easy. If you will observe our interval, okay, our numbers on our y-axis differ from 125, right? So it means between 120 1125, the difference is 125, so it's in the middle. We just have to divide 125 by 2, so approximately that is 62 point something, right? Okay, 62.5 to be exact. Okay, so if we have to estimate how much the server will earn if they will serve 225 tables, it will be about, okay, 1060. Okay, a rough estimate of that one, not to be exact. Okay, so our answer will be this one. We can predict that the server will earn about $1,060 if they will serve 225 tables in a week. Okay, so this line of it is really a good prediction. Okay, if you're going to have a target on your own. Okay, on, like, if you will be the server here, if you want to earn like a certain amount of money, you should know how many tables you have to serve in a week as your target, as your goal. Like playing games, right? You have to learn what's your goal points, okay, so that you have to work for it. Okay, that is very easy use of our line of feet to make prediction or conjectures. Okay, moving on for our last topic, we are going to have the equations of our lines of feet. And this one is in connection with our lesson before. Remember, we have our equations of line in the form y equal to mx plus b, our slope, intercept form of our line, wherein m is our slope and our b is our y-intercept. Okay? Remember, for our slope, we have the ratio of the run over the rise over the run. Or if you have your points, remember you have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's what we use. Okay? For the y-intercept, it's only a point along the y-axis, right? Wherein our x-coordinate is 0. For this one, that's our y-intercept. Okay? That's why for this example, as you can see, this is our rise. This is our run. Okay, we have 20 points for the rise, 15 minutes for the run. So our slope is 4 over 3, or in decimal is 1.33x. Okay, and then plus our y-intercept, which is estimated as 47. That's why the equation is 1.33x plus 47. That's how we make the equations for the line of feet. Okay, let's apply that one for our examples. First example. So you can write an equation that approximates a set of data. Okay, the scatter plot shows the amount of food collected and the number of volunteers who participated in the food drive. So let's write our equations for our line of feet. Okay, so again, remember, we need y equal to mx plus b. So we need to find our slope. Okay, to get our slope, it's very quick and easy. Just find 2 points on our lines of feet. Okay, remember the ones along the line to make our life easy, not the one in the middle. So let's say this one, right? And also this one. If you read these points, right, we have this is 40 and 15, and then this one is 80 and 30. Okay, so we can actually follow our format, our rule, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, let's find our slope. Remember, this is x sub 1, y sub 1, x sub 2, y sub 2. So we just have 30 minus 15 over, okay, 80 minus 40. 30 minus 15 is 15. Okay, 80 minus 40 is 40. If you simplify 15 and 40, that will give you 3 over 8. So our slope will be 3 over 8. Okay, and then let's have our b. Remember, our b is very easy. It's this one. That's our b because this is our y-axis. So our b is 0. So using this one, we can now write our equations of our line of feet. It will be simply y equal to 3 over 8x plus 0. So we don't have to write plus 0 anymore. It will just be y equal to 3 over 8x. That's it. Okay. Miss, what if there's no fraction in our choices? We can actually use our fast calculator to find out what is 3 over 8 in decimal, right? So we just divide 3 over 8. So this can also be represented as y equal to, okay, 0.38 x, because 3 over 8 is 0.375. Okay, so rounding up to two decimal places, it will be 1 equal to 0.38x. Okay, so that is how our equation of our line. We get the slope, we get the y-intercept, very quick and easy. Okay, it will help you also to predict, okay, what will be the number of food in tons if you have, let's say, 200. Okay, 200 volunteers. Okay, how many amount of food will they collect? Okay, we don't have 200 uh, in our graph, right? So if we want to predict, what if we have 200 people? Okay, our volunteers, you just have to do the amount of food will be 0.38 times 200. Okay, so 0.38 times 200 will give you 76 pounds. 76 tons of food, right? The more volunteers, the more food that they can collect. Okay, so that's why we come up with our equations for the line of fit, so we can predict, okay, make conjectures about data that are not represented in our scatter plot. Okay, I hope you understand how we find our equations of line. Okay, let's try to get one more example. Okay, example number 6. So we have here the scatter plot show the amount of time Mia spends practicing the piano and the number of mistakes she made. Okay, so let's make our line equations of our line of feet. So remember, we have y equal to mx plus b. Let's find our slope by getting our formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so let's find points here. Okay, lying on our line, which is, let's say, okay, this one is, oh, this one. Okay, and also we can use this one. Okay, so this one is 4 and 1, and then this one is 2 and 6. Okay, so remember, it doesn't matter which one you put, x sub 1, y sub 1, x sub 2, y sub 2, it will be the same thing. Okay, so our y sub 2 is 6 minus y sub 1, which is 1, over x sub 2 is 2 minus 4. So 6 minus 1 is 5, and 2 minus 4 is negative 2. So we have a negative slope. Okay, and as you can see here, right, it's like decreasing negative association. Okay, and then our b is this one. Okay, let's just estimate that our b will be 11. Okay, the point on our y-axis. So therefore, our equation will just be y equal to negative 5 over 2x plus 11. Or, if you want a decimal, it will become 5 over 2 is 2.5. So y is equal to negative 2.5x plus 11. That is our equation for the line of feet. Okay? So we have a negative association here. Okay? And as you can see, our points are also close to our line of feet, so it's a good fit as well. Okay, so that's how you make the equations of our line. Again, you need the slope and you need the y-intercept. Okay, by the way, if I would like to go back to my previous example for the slope, okay, if you don't want to use our y sub 2 and y sub minus y sub 1 over x sub 2 minus x sub 1, remember our points are here. This one, let me put a red one. This one, and then this one, right? If you don't want to use y sub 2 minus y sub 1, and it's very easy for you to count the rise over run, that will also be a good technique. So for example, here the rise is, this is by 5, so 5, 10, 15. So I have 15. And then for the run, we have 5, 10, 15, 20. So I still have the same slope, 15 over 20, right? And that is 3 over 4, right? Since a while ago, it's the same thing, okay? So if it's easier for you to do this one, so that will be fine, okay? But you can always use our formula to get the slope. We have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so now let's use that one to answer this equations of line and interpret the slope and the y-intercept. So the scatter plot shows the amount of time different students spend studying for a test and their test score. So let's write an equation that best represent the line that is drawn. Okay, let me give you a quick technique on this one. Remember our y is this one, okay, and it's all positive. So we can actually eliminate two choices already for this question. It means it will always be our y equal to mx plus b will be y equal to something, our slope, x, plus this one is 40. It's positive. So we can eliminate that B and D will be wrong. Okay? So all we have to figure out is our slope. Okay? It's either A or C. So let's have our slope. So let's find our point. Let's say this one. Okay, and this one is a perfect point. So we have here 30 and 80. And then for this one, 45 and 90. Okay? So let's use our formula. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Why do I ask you to use the formula just to be exact? Because sometimes we might forget that we only counted it by 1, wherein the interval is by 5. So it's better to use the formula to make it for you to be sure. Okay, so x sub 1, y sub 1, label your points so you will not be confused when you use the formula. So it will be 90 minus 80 over, okay, 45 minus 30. So 90 minus 80 is 10, 45 minus 30 is 15. So 10 over 15, 45 minus 90. Are you correct? 45. Oh, sorry, it's 45 and 100. That's why. Okay, let me just correct on that one. This one should be 100. Okay, 100 minus 80 should be 20 over 15. Okay, I'm so sorry, I made a mistake in this is 100. So 20 over 15, that is actually 4 over 3. Okay, or in decimal, that is actually 1.33333 and so on. Okay, so therefore, it's very clear that our answer will be letter C. Okay, so our answer will be letter C. Okay, so y is equal to 1.33x plus 40. Okay, that is our equation of our line. Okay, now let's interpret our slope and the y-intercept. Okay, so for our interpretation, we can say that, okay, so remember our answer is letter C. Okay, so a student test score increases about 1.33 points each minute, okay, because of this one, okay. Our slope is 1.33. It means that for every minute that we are adding, okay, your test score is increasing by 1.33, okay. And then It also means if you have a 40 points, okay, if your x is 0, you did not spend time, okay, studying for the test. Therefore, your score will just be about 40 points. Okay? If you did not study, your score will be 40 points. But if you study even for a minute, it will add to 1, there will be 1.33. So if your x is 1, you spend 1 minute in studying, it will become, let's say, 40 plus 1.33, your score will be 41.33. So it will be increasing at 1.33 every time, okay, you study for additional minute. Okay, so that's the meaning of our slope and y-intercept for these lines of feet. Okay, I hope you understand that one. Moving on to our last example. Okay, our last example is this one. We are going to make a conjecture as well about this line of feet. So let's try to find out our equation. So just like what I told you a while ago, we can eliminate two choices, the minus, because our B here will be positive. Okay, so B and D are not possible answers. Okay, so we're looking for our A or C. Okay, so let's find, so we have y equal to mx plus b. We already know that y is equal to something, our slope x plus 44. Okay, let's find 2 points. Okay, observing this one, I would like to select this and also this one because they lie on the line. It's easier, okay? So for this point, that is 1 and 40. This one is 4.5 and 25. Okay, let's label x sub 1, y sub 1, x sub 2, y sub 2. Let's find the slope. Remember, the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we have 25 at 40 minus 25 over, okay, 1 minus 4.5. We know that 40 minus 25 is 15. And then 1 minus 4.5 is negative 3.5. So if you will divide 15 by negative 3.5 using your calculator, your fast calculator, it will become 4.285. So let's estimate it as negative 4.3, rounding up to the nearest 10. So therefore, our answer is letter A. Okay, so our equation will be y is equal to negative 4.3x plus 44. Okay, now we are going to use this equation for our line of feet to make a conjecture about the gas mileage of a car if it weighs 5.5 tons. Okay, because in our scatter plot, we only have until 5 pounds. So what if x is 5.5? Okay, very quick and easy since we have the formula y is equal to negative 4.3x plus 44. We just replace x with 5.5. So you have y equal to negative 4.3 times 5.5 plus 44. Okay, use your fast calculator to input everything in your calculator to make your final answer. So we have negative 4.3 times 5.5, that will give you negative 23.65, adding to 44. So plus 44, you're about to have y is equal to 20.35. Okay, so therefore, if the car weighs 5.5 tons, okay, our gas mileage will be 20.35. Okay, 20.35 mpg. Okay, so there you have it. You know how to draw the line of feet. You know when to say it's a good fit or not a good fit. Remember, it's a good fit if the points lie close to the line of feet. It's not a good fit if they're scattered. Okay, and always remember to draw the line of feet at the center, wherein half of the points are above it and half of the points below it. Okay, and to write an equations of our line of feet, remember we need a slope and with arrow wire intercept. For the slope, we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? And then, okay, remember our intercept, it's always on the y-axis. Okay, so there you have it. That is our lesson for today. Okay, so what do we do now? We only have one activity after this. We're just going to have an Alex activity about the line of feet. Okay, please remember, okay, to accomplish these two activities. And also, before you end this video, if you know, okay, if you want to receive a prize, just tell me how do we say good morning in Philippines. Okay, there are two ways. But the clue is the first word that I said in this video is the answer. Okay? I know you will Google it, but it will give you a different answer. Okay? Okay, remember, you got this one. Okay, just finish your Alex activity. And if you still have any question, feel free to ask me questions. And you always can always go back to the to the video, to the part that confused you. Okay, thank you, and I'll see you again next time.